Okay, so we're back with the third video, and we've talked about how we're going to put the camera into this character, right? So today I'm going to talk about a thing called parent-child hierarchy. Okay, parent-child hierarchy. That means a child will always follow the parents, meaning the parent always supersedes the child, while the parents never while the child never supersedes the parent. Now we can also see that dynamic inside of what we call as a hierarchy. So we will try and establish a hierarchy between the third person controller and the camera that we're going to make. Now, for the bright people out there, you might automatically guess that the camera might be the child because we want the camera to always follow the parent. But don't worry, nobody will guess that unless they have experience in Unity. So let's get ourselves going. So click Game Object, go to Camera, and you're going to have this camera thing on your Unity scene. Now, mention the camera preview. This scene that you're seeing on the small screen at the bottom right is the same thing as what you're going to see in the game. I can drag this game and I can put it out here, rescale it, and see that the camera preview is the same as the game. Now notice that I shifted these tabs. These are very useful when you're trying to multitask, when you're trying to shift other types of windows. Basically, you can create your own layouts, as you might see in here. Go to the layout, and you can do all kinds of preference stuff. 2x3 is where your scene and game is maximized, and all of these guys are squished to the right. If you do not want this, 4-split. 4-split is you have the y-axis in 2D, the z-axis right here, and the x-axis. So you can, this is really useful when you're using the hand tool or modeling. You can see that this guy is doing its CT scan, right? It's really cool. This is the top view. This is the front view. As you can see this guy's this glassy face. It's a little bit creepy because we don't have textures. And you can have a left view. Okay, so this is not indicative. This is useful when you're doing 3D modeling. So for any arts people who are watching this video, you're going to always play with this view when you're modeling 3D characters. Okay, you can do tall. Notice I skipped default because that's what we're always dealing with. Tall is this entire scene slash game is super big. Everything's squished. You can say wide. Everything is in a cinematic view like IMAX, and these guys are squished to the bottom. This is a relatively okay in my size. Depends on your work habits or work style. I would just set by default because I am that vanilla guy. All right, so let's go with the camera. So right now you would see nothing because you want to click this arrow button. As you can see, this is also a parent-child hierarchy. Sample scene is the parent, and when you click the arrow, that means show their children, show the scene's children. Since the scene is the entire game itself, the children in that entire game is equal to the rest of all of the objects or all of the things that we see, can interact with in the game. That's the children. Now, let's put the camera inside of this guy's object, all right? So already you can see that arrow key in here. When you click that, hey Ethan, watching this? So this is called Ethan body, Ethan glasses, Ethan skeleton. I know skeleton's a little bit creepy, but all characters have a thing called a skeleton because they want to move. If you do not have a skeleton in a video game character, you cannot animate that character. But that's for a very far video, but soon enough video, okay? So these are all children of this controller. Notice that when I click the controller, you see this green cylinder-like mesh or cage, I would call it, okay? Now, what is this mesh or cage? This is what you call as what you can interact with the outside world. Basically, your arms, basically the entire skin that the character's having, this is transparent, meaning that although we can see it visually, when the arm passes through, well, let's say a sphere. Let me just create a sphere quickly. You're going to, I'm just going to bump it up. You're going to overlap with the hand. Basically, when a character moves, in the previous video, you saw the character, the first-person controller, interact with the sphere, trying to penetrate the sphere, but never ever doing that. In this case, the arm will go through the sphere because, as you might see, the arm is outside of this green cage. Now, in other words, the green cage is the only collider that's going to interact with the overall environment. Everything outside the cage is going to go through. Can you see that pattern? So, that also means that this Ethan character or this entire model is not a collider, it's actually only a visual representation of what the user or the player can only see in their game. But these guys are never going to interact with the environment itself. Now, why is that? That's because we want to prevent lag, okay? Lagging. Imagine these complex curves, these complex fingers, these belts, these wrinkles, all of these clothes to glasses to hair, all of them trying to collide with a sphere or trying to collide with any type of game object. It will definitely lag because computer, what it does in the background, it will check for every little single vertex, every little single side in the environment to see whether if it collides with that object or with the object around it. So it's going to lag very hard. That is why we create a simpler mesh, that we call it, simpler collider, which is this green boring cage, but it's very effective and efficient, and that's all we only need in our video game. We're not going to have that such a detail. Nobody's going to notice. Well, some of us are going to notice, but it's not going to affect the game. So, first lesson that we can learn in video game development, always focus on the efficiency versus quality, because quality does not necessarily mean that the game is always good. Think about lag, think about performance, and think about memory usage, because that is all what's all about. Imagine Clash Royale lagging super hard. Imagine your favorite video game such as Minecraft running at 5 frames per second. You're just basically seeing a photograph just shifting every second. It's never going to work. You're not going to play it. Same thing with this game that you're going to make. Always think about efficiency. All right. Parent-child. Let's do this. So how do I do parent-child? Simple. Drag and drop. And as you can see, camera is in the third-person controller. Okay, now let's see whether if this parent-child mechanism works. Click the third-person controller and let's move this. As you can see, everything moves with it, including the camera. As you can see. Rotate it, just to make sure. The camera rotates with the parent. You see that? So it's a really, really awesome mechanism. Parent-child hierarchy system is basically it's the most important part in Unity because you have to organize your game objects. Everything is called game objects, okay? Basically, you can do this type of thing. You can adjust your camera to make it into third-person view, right? And you can see your character as it kind of moves. Now, I'll show you a cool feature. Now, let's go out of the camera. Did you see the transform thing change? Let's do that again. Camera, 0.27, 5.917, 1.088, drag, drop, suddenly it changes, 0.07, 1.35. You see that change? Now, why does this position change? That's because the child always bases all of its values according relative to the parent, meaning that these values are distances from this character or distances from the parent. So the camera's position that we see is relative to the position of this parent, the third person controller. Basically, try this out. On the x is 0.19, right? Depending on the value, if it's positive right here, add 0.19 to 0.07 approximately is 0.26, right? About 0.27, right? Because it was, let me check that again, 0.07999999, right? You can see that it just merely subtracted its position from the parent, which is a third person controller. Same thing with y, same thing with z. So you can see that all children are relative to the parent. So that's a really useful tool when you're trying to edit coordinates through hand. Let's say I want to edit like 0.8. And that shifts here a little bit weird. Oh, the middle's perfect, right? Because, you know, always relative to the person's coordinates. And you always want it to be in center. The third person controller's center is 0 in the camera. The y, I want it to be tall and high, so about 1.390, right? Z, I want it to be further. I want to see its legs. Kind of do that. Now let's try and run this. See how we go. All right, so this guy is already animated. You see he's in idle state. Move around. Look at him. He is moving. Okay. It's a little bit wonky because, hey, I didn't program this. Haha. It's really wonky because it doesn't go where I want it to be. No. Okay, anyways, so play around with it, and we have learned about parent-child hierarchy and about the first lesson on video games. So I'll see you guys in the next video. We're going to do some more advanced features.